Hello viewers, welcome to my channel. I'm Tips. And today what I'm going to do is the final stock pot refining series video. We're going to refine this black mixed PGM powders into some pure metal. Before we get started on the refining, I'd like to talk about my new camera here just a little bit. It's a Sony model RX100 Model 6, and that's a wonderful camera. It takes beautiful video, but I want to talk about three things that I noticed that are drawbacks about owning this camera. Number one, you got to have a special memory card in order to be able to shoot high definition video. I got it home and I put my regular old SanDisk memory card in, and it says I cannot use this card to shoot in high definition mode. This is the card that I had to buy. It was about 50 bucks. It's a 128 gigabyte special card for high speed memory for use with the high definition 4K video. Number two, the battery charger. It does not come with an external battery charger. It's got a little port right here, and you got to plug the battery charger cable into the wall or into the PC and then into the camera in order to charge the battery. Third thing that was a drawback on this camera is this thing's got a lot of heat going on in it when you're shooting high def, and it will only shoot about 5 minutes continuous high definition video before it starts to overheat, and it will shut down automatically after 5 minutes. It'll shut down even shorter if the ambient temperature where you're filming is high. So if you're up in the 90s, it might only last 3, maybe 4 minutes, something like that. But I just wanted to talk about this just a little bit. Now, we're going to get to the refining of the stock pot metals coming up right now. What I'm going to do now is, to begin this process, is rinse the broken glass out of here into this beaker. You use hydrochloric acid. There is 7 grams of material in here. If you remember from part 15. And so the critical concentration for this next step is going to be 20 ml per gram of material. I'm going to transfer this solution into this beaker, so we got it all in one beaker, and then we'll start the process of dissolving it. Got the material down here in the bottom of this beaker now. What I'm going to do is put it up over here onto the stir plate. I'm going to start stirring. Got a stir bar here, put that in. Start stirring this, and I'm going to add some heat here. Start heating this up. It's been on the heat now for about 15 minutes. We've got 192 Fahrenheit, 88.8 degrees Celsius. What I'll do now is begin adding some 40 volume hydrogen peroxide. Got this at Sally's Beauty Supply. It's about 12% hydrogen peroxide solution. Here we go. There we go, that's what we want to see. Gotta add it slowly or it'll boil over. This will be my 5th dropper of hydrogen peroxide. Adding it in just a little bit at a time. Reach in here and get a temperature on it right quick. We're at 103 Celsius, 218 Fahrenheit. What I'm waiting to see here is the reaction become subdued or a little bit less as I add this hydrogen peroxide, and that'll let me know that the metals have gone into solution. Alright, I've been adding hydrogen peroxide now for about 10-15 minutes, and this line right back here on the beaker is my limit. I want to get all the metal dissolved before I get to that line so that I have the right concentration. So I'm going to keep adding some hydrogen peroxide here. It's not as vigorous. I've noticed that it calmed. It's not quite as reactive now. I think most of the metals have gone in solution. As I add the hydrogen peroxide, I can add a whole dropper here. If I'd have tried to do this in the beginning when there was a lot of metal in there, it would have overflowed on me. So that tells me I'm getting close to getting everything into solution. The nice thing about dissolving the metals with hydrogen peroxide and hydrochloric acid is there will be no nitric acid involved here, so I won't have to worry about denoxing this solution before I go to the next step. Alright, I think we've just about got everything in solution that's going to go here. Still foaming up pretty good when I add that hydrogen peroxide, but I think I've got everything in solution. I'm going to turn this off now and let this cool down. Actually, I'm going to let it spin. I'm just going to turn the heat off here. Let's get a temperature reading here. I've allowed it to cool for half an hour or so. I've got 88 Fahrenheit, 31.2 Celsius. Now what I'm going to do is I've got a filter set up here, and I'm going to moisten the filter with some hydrochloric acid, and then we're going to filter the solution, because there might be some pieces of glass in there. I'm just going to go ahead and filter this out. I've got a tiny filter paper here. And once we get the filter in here, we'll be able to see what we got left to dissolve, if anything, down in the bottom of this beaker. Okay, we're getting down to the bottom of the beaker here. I'm going to put a magnet on there to keep the stir bar in so it doesn't come flying out of there. And as you can see, all the metal has been put into solution. There's no solids left in the beaker there. And that's what we want to see. Now I'll rinse everything out of here with some hydrochloric acid. And all that's left in the beaker there is a little few shards of glass. It's all rinsed out. I've got everything going through the filter now. We're looking good. Filtering is complete. I'll save the filter here and put it in my paper storage. And what I've got here is a piece of filter paper on the end of a bamboo skewer. Stick it down into our solution. Get a little bit of our solution on the end of the filter paper. Now I'm going to do a Stannis chloride test. And you see that we've got precious metals in solution. I'm going to transfer my solution into this tall beaker right here. And we're going to get ready to precipitate out the platinum with some ammonium chloride. We're going to set this off to the side over here. This is our solution. It has the platinum group metals. What I want to do now is make a saturated solution of ammonium chloride so I can precipitate out the platinum. I'm going to add some distilled water, dissolve this ammonium chloride. Alright, here I go. All set up to do this. I've got my platinum group metals here. I've got my ammonium chloride solution concentrated here. I'm going to go ahead and pour this in and see if we can get the platinum to precipitate. Also, the ammonium chloride is needed to go to the next step and get the palladium. Alright, here we go. This is where I messed up last time I tried to do the video. Okay, as you can see, this is our ammonium hexachloroplatinate down here, platinum salt. It's fairly pure looking, yellow colored. What I'm going to do now is rinse down the sides of the beaker with some hydrochloric acid. Alright, here's my lack of experience shining through again. I think this is the platinum salt, the yellow colored material at the bottom of the beaker. Up here at the top, this dark colored liquid should be the remaining palladium in solution. And that solution needs to be, yeah, it's brown and green color, which is how the palladium looks. Might be a little bit of platinum left in there. I see a little bit of orange in my test. So I may need to add a little bit more ammonium chloride here. Here's my Stannis test. You can see it's green, but there is a little bit of orange in there. So I'm going to add some water to this undissolved ammonium chloride and add that to our beaker, see if we can get some more platinum to precipitate. Based on that last Stannis test, I'm going to dissolve a little bit of this ammonium chloride here with some distilled water, and we're going to add that to the solution and see if we can get some more platinum to come out of solution there. Okay, here we go. We're going to see if we can get some more platinum to come out of solution here. If it does, that solution, that dark colored liquid on top there will turn cloudy with a little bit of yellow in it. And I don't see a lot of that coming out of solution, so we must have got everything dropped. I didn't see any more platinum coming out of solution there, but that's okay. I need excess ammonium chloride in this solution for the next step to get the palladium out. Here we are. We've got our platinum salt down here, our palladium solution sitting above it. What I'm going to do is filter out the platinum salt, get it into this filter paper, and then recover the palladium solution in this flask, and then I'll rinse off as much of the palladium as I can with some 15% ammonium chloride water. Go ahead and do that now. This is ammonium chloride water. I'm going to moisten the filter paper with the ammonium chloride water. That brown liquid is our palladium solution. Here's our platinum salt. That yellow material right there is our platinum. And this material is soluble and plain tap water. So what I'm going to have to use to get this out of here is some of this ammonium chloride water. This is a 15% solution of ammonium chloride. And I'll use it to rinse the platinum salt. Whoops. Rinse the platinum salt out of the beaker. Once again, this platinum salt right here is soluble in water, so water can't be used to rinse it out of the beaker. It'll dissolve, go back into solution if you try to use water. Here's our nice platinum salt. What I'll do now is I'm going to add the rest of this ammonium chloride. Well, first let me rinse the platinum out in this funnel. I'll say it one more time. It's important to understand that this salt can't be rinsed off with plain water. Plain water will cause it to redissolve. That's why I'm using 15% ammonium chloride water to rinse it off. I'm going to add the rest of the ammonium chloride that we did not use earlier into my little bottle here. Save it for my next batch. Here's our platinum salt, all filtered out of the solution. What I'm going to do now is transfer that funnel with the platinum salt into this little container. Somebody was asking about this container recently. It has platinum salt in it from previous videos. And what I'm going to do is I'm going to add this to this. Okay, we're going to go ahead and wrap the video up right here. This is our platinum. It's getting a pretty decent collection of platinum in there. I'll refine this in a separate video. This is our palladium solution that's heavily loaded with ammonium chloride. And what we'll do is in the next part, part 16, I'll process this and we'll get some pure palladium out of it. This will conclude part 15 of the Stockpot Refining series. I was able to get some platinum salt and I combined it with my other platinum salts that I've been saving. I have yet to get 1 milligram of platinum metal from all these experiments that I've done. And what I intend to do is redissolve this salt and process this all by itself and try to get some pure platinum. This is going to be like it sits. I could burn this and get the platinum sponge, but it would be full of palladium and possibly other platinum group metals. So I'll have to do this in a completely separate video. But anyway, I got me some platinum out of my stock pot. I don't know exactly how much, but at least I got something to show for it. The other thing I have here is the palladium in solution. And what we'll do with this is going to take another video to get this done. What I'll have to do is bubble chlorine gas through this with a chlorine gas generator, and it will form a compound of palladium that is then soluble in ammonia, and I'll dissolve it in ammonia and then filter it out and then reacidify it with hydrochloric acid like I've done in my previous videos with the palladium. And then we'll get the palladium salt, the pure palladium salt, out of that process, and we'll melt that up into a nice button and offer that for sale on my eBay store. This will conclude part 15 of the stock pot refining series. Thanks for watching.